none of you was too bored. All of you woke up after the jet lag. In this 10 minutes talk, it is going to be a warm-up. Afterwards, James will come back and he'll give you the serious stuff. So all I tell you now is what you can tell your mothers, your sisters, in case they don't do economics or math or statistics. This is something you can take home, or even something you can take home when you talk to your ministers, those that do not have any economics degrees or statistics, or in case they forgot all of the little math James is teaching. So, to remind you that this is not working. 1 second. It's coming. Okay. So, to remind you of what how Sabina ended her last lecture yesterday, she said, or something we do, I think I have to stand here. Okay. Maybe it's a sign to go slowly, right? So, do you remember these matrices? One on the left, one on the right. In this, let's say, this is one region of Mexico, and that's another region of Mexico, right? We have 4 people in each of them. And we are interested in 4 indicators. Now, we saw in each of the regions, if we use a normal dashboard as we have in our yearbooks, and as we have in our annual reports, it's something we've been publishing every year. We see 25% are deprived in income, right? 25% are deprived in education, 25% are deprived in shelter, 25% are deprived in water, correct? What about the second region? We get the same figures, right? But do you remember the difference? Or do you still see the difference between these two distributions? What is it?
It's only one person. In the second joint distribution, all the deprivations are for the same person. The others, in the first joint distribution, the deprivations are distributed among the different individuals.
Exactly. Is that clear? Everyone can see that, right? Now, what we are trying with the MPI is to go one step ahead. We can count for each indicator. We can calculate for each indicator the percentage rates that are deprived. We can have for each of the indicator a separate headcount ratio, right? However, the new thing that we're trying to estimate is, I don't know where the Bluetooth stick is. Is it in that computer or in this computer? The simple question we want to answer is, and that is what we're going to do in the next couple of weeks, how many people have more than 1 deprivation? How many people have more than 2? Or 30% of the weighted indicators we have. So instead of asking how many people are deprived in 1 deprivation, we are asking how many people are deprived in 1 or more indicators at the same time. So instead of counting column-wise, we start counting row-wise. And for that, I can give you a simple example. We can get good information then, based on cutoffs we choose. We can say, for example, 16.1 million people in all over the world are deprived in all of the indicators we have in the global MPI. Only 16 million. But if we look at only one indicator, we can say 5.2 billion people, 3.9 billion people are deprived in 1% of the weighted indicators. That means at least one indicator or more. So we can get at something that is the intensity. Now this Bluetooth is not working. No. So to warm you up, we have a little example, a very small and very intuitive example, and I hope this will set the scene for what James will do later and in a more rigorous manner. So assume we have 4 people, 4 persons, and 4 dimensions. And these people are very famous. One is called Usha, the first one, right? In how many indicators is she deprived in? We're looking at schooling, food, water, and housing. So she's not deprived in any one of them, right? Then we have someone who arrived today, and I think he hasn't introduced himself yet. So his name is Ayush. He's come all the way from Mumbai.
Hello guys. Sorry for coming late. I am Ayush and I work for the tribal development department there. And clearly I am deprived in schooling, that is for sure.
You want to do a PhD one day, right? Good. And how's your house in Mumbai? Is it very big?
You know Mumbai. I don't know.
You lived there. You lived there for a couple of years, right?
Yes.
So in Mumbai, housing is very difficult. It can be very, very small, right? So he's deprived in schooling and housing. Let's skip this one. We have another guy here, Stefano. I can see he's waiting for lunch already. He's come all the way from Tanzania, 24-hour flight. Now, he's deprived in food, but nothing else, right? And then a very poor fellow here. His name is Chris. He's deprived in schooling, food, water, and housing. All right? Now, the question of the day is, who of these people is multidimensionally poor? Chris, any other ideas? Ayush says he's... What about Ayush? Yes? What about Stefano? Why not?
I would say yes. Because he's deprived in at least one.
In at least one. Okay. And it's a very important one, right? Food. So, clearly we have different answers now. Some say 4, some say 2, some say 1. Depends on the cutoff point?
Yeah, there should be some cutoff.
So we need a cutoff. Okay. So first, before we set any cutoff, let's count, right? And we have done that already. There's Usha at 0, Ayush has 2 deprivations, Chris has 4, and the last one only 1, right? Now, let's set a cutoff to 2, right? Anyone that has 2 deprivations or more is poor. Who would that be? Remember what James taught yesterday about the headcount ratio? How many people would be deprived, are deprived in 2 or more? 2. So the headcount ratio would be 2 out of 4. So our headcount ratio is 50%, right? I pointed here. So these 2 are deprived, 1 and 2, 1 and 4. So we have 2 out of 4 people are deprived, are multidimensionally poor, right? 50%. Now, if that was all, we could all go home now, right? But we want to know how poor are the poor. We see Ayush, he's deprived in 2 out of 4, right? The third person, he's deprived in 4 out of 4. On average, and that is now similar to something we had yesterday with the poverty gap. With the poverty gap, we wanted to calculate the distance, right? How far are the poor from the poverty line? Here we want to ask, how poor are the poor? So it's 2 out of 4 and 4 out of 4. On average, these 2 are deprived in 2 out of 4 plus 4 out of 4 divided by 2. I know that's very difficult in the morning. It's maybe class 5. And those of you who have children, they might be learning that. 2 out of 4 plus 4 out of 4 divided by 2 is 6 over 8, or 3 out of 4. Now, if you don't believe me, we can do something Sabina introduced yesterday, the counting approach. So all of this is the Alkire-Foster method. It belongs to the family of counting approaches. So we can count 1, 2, 3, 4, 5, 6 out of 1, 2, 3, 4, 5, 6, 7, 8. So 6 out of 8 is what we get here by taking the mean of the average deprivations of the poor, or by just counting the deprivations of the poor. We neglect this deprivation of the non-poor, right? So the intensity of poverty is 6 over 8. That means we now have 2 values, 1 for the headcount ratio and 1 for the intensity. The headcount ratio 2 out of 4 and the intensity 3 out of 4. If we multiply the two, we get our MPI. 2 divided by 4 times 3 divided by 4 is what? 6 divided by 16. 6 divided by 16. Again, if you cannot follow this multiplication, you can count. 1, 2, 3, 4, 5, 6, the deprivations of the poor. And where do we see 16? All of it. 4 times 4, right? 4 times 4 is 16. The deprivations of the entire population could face, right? 6 over 16, that's our MPI. So we can count, or we can multiply H times A. Is that clear? And James will do that in a more abstract way, in a more rigorous manner, but that is essentially what the MPI is. We have something called the intensity, something called the incidence, or the headcount ratio. We multiply the two, we get the MPI. Now, why has this become so attractive and has been implemented in many countries, almost all over the world now? It is because this matrix, one of the OPHI co-founders, John Hammock, he does not have a math or statistics degree. He does not do any fancy data loops. So whenever he went to policymakers, he taught this in his own way. And he could tell the policymakers the next step and said, look, if we do the following, say we measure poverty, and in the next year we have an intervention. We see that this guy, for schooling, or that you can imagine the third row being a region. Let's say we have an intervention. We give all the kids over there scholarship, so that this region is no longer deprived in schooling. What happens to the MPI? What happens to H? What happens to A? Yesterday, James taught something about the monotonicity. Do you remember? And the headcount ratio was not adhering to that axiom, right? So here, what happens? What happens now to the headcount ratio? If if our cutoff is still 2, how many people are poor? The same. What happens to the intensity? It decreases. What happens to the MPI? Are you following? Okay. So now the intensity changes because the third person is no longer deprived in 4 out of 4, but 3 out of 4 deprivations, right? So it's no longer 6 over 8, but 5 out of 8. We can count again. We can say 1, 2, 3, 4, 5 out of 8, right? That's A. 5 out of 8 is A, our intensity. And the MPI is now 5 out of 16. Where do we see 5 out of 16? If we count the deprivations, 5 out of 16, right? So the MPI changes and A changes, even though the headcount ratio stays the same. And James will talk more about that. He will remind you of the axioms. He'll remind you of the monotonicity principle. So, in a nutshell, that is the MPI. And really, the new thing is the intensity. It is no longer just the headcount ratio of poor people. It's really about how poor are the poor. And is the intensity of poverty changing over time? And we'll have many lectures for that in the coming days. Yes. So we have 1 or 2 questions, and then James will take the floor. Thank you very much. Yes. Yes, I get it. Yes.
In Mexico City, some people and some neighborhood has access to water 3 times a week. So what implies for an urban area?
Yes.
That in case that the income and be not present at school. Sorry.
Okay.
Sorry. Okay.
It was
what
clear.
I want to
Yes.
know is about details of housing. the materials of how the house is being built, and how we consider a scale, or what has been learned? Thank you.
All right. It's a very important question, and we'll talk more about that actually from this afternoon onwards. But what I was hiding here was that for each of the indicators, we have a separate cutoff. And James will talk about it also in this next lecture. So for schooling, we can set a cutoff to 10 years of schooling. Maybe in Mexico, you want 13 years of schooling. Or if you focus on a particular region, if you have an MPI, say for Yucatan, you say in Yucatan schooling, the minimum we want for every child should be 10 years. Whereas if we go to Mexico City, it should be 50. So we can vary those. However, when we build one index, normally we take the same cutoffs for every person, for all the regions, to have a proper comparison. So for each of the indicators, there are underlying cutoffs. James will talk about them. We'll talk about it later in the normative decisions presentation. And these are important questions we can then talk about. Yes, one from Ziggy, and then I see James, he's very anxious to talk. Yes, Ziggy.
All right. Thank you, Ed Sheeran. I'm sorry, Dr. Oldiges. I just wanted to point out something. As a policymaker, over time, you, as you have explained, or I think Professor James explained, that, for example, for the last person who is actually, who is the last person, Ricardo? I'm not sure. On the matrix, that person, since he or she is below the cutoff, then automatically it will become a 0 instead of a 1. So it will not be counted. So you will only count the deprivations of the people who are multidimensionally poor. So as policymakers, we always have this issue where we say that we don't want to leave anybody behind. And I just want to throw this question out there to see how can, after cleaning this data and having the final result, how can we still view and action on the people who even if they are not multidimensionally poor, they are still suffering deprivation.
Thank you, Ziggy. Very important question. James will touch on this, I'm sure. Okay, please. But I think I remember something from his lecture yesterday. He was talking about censoring, right? And that's the same thing I have done here. We basically censored this deprivation. And now you're saying that information is lost, and we don't take it into account. However, when we use our Stata files, or even when we use Excel, we keep track of that. And you learn something that is called the raw headcount ratio and the censored headcount ratio. So we will always have something, we will always know from this one that 50% of the people are deprived in food. We do not neglect that. However, when we look, the moment we set a cutoff, poverty cutoff, we know only 1% of the poor is deprived in food. So we keep both the informations, we make use of both of them. Now, I turn over to Professor.
Thank you so much. Really, really good. I'll take that. The clicker. Oh, the clicker. Yes. Thank you. Right. Well, hello. Good morning. I hope everyone's awake. I am. Did anyone exercise this morning? Very good, very good, very good. Walk a long distance? Okay, so some of us are ready to go. I want to answer your question, by the way. There are many ministries in government. One ministry is the Ministry of Education, and one ministry is the Ministry of Social Development, called Coneval here. The Ministry of Social Development would be interested in who's poor and helping the poor rise above their lines, their cutoffs, their barriers, preventing them from being like the rest of us, okay? Whereas the Ministry of Education would be interested in everyone's education. So where would your question be handled in? The Ministry of Education. Who would be interested in the poverty measure we're talking about? The Ministry of Social Development. So that's how I would define the two. Of course, everyone keeps all data. But for poverty, you focus on what the conditions of people who are poor are, however they are defined. It could be defined by income, and then you would ignore all the people that had all the low education. Every single person would be, unless they happen to be income poor at the same time. See what I mean? Okay. Great, well, let's move on. Could someone please load my lecture so I know what I'm going to talk about? Hello? Yes. I'm James Foster. I am going to give a talk here, if I can. Or I could wait. Any questions, anyone, while we wait for my lecture to load? Ooh, I sent it to Usha this morning very, very early. I have it on a memory stick if I go through a whole process. Let's see who's quicker, huh? I'm trying to beat it, in case someone has found my lecture. Oh, right, I have it here. It's 100. You got it. I won! I won! The problem, there's a delay on this. And so I go, hello. And I hear hello here, and then I hear hello there. It's really interesting, isn't it? Okay. So the previous speaker was kind enough to give a description of our approach that would be appropriate for all of you here to tell your brothers and fathers. Consequently, I am going to talk now about the approach from the point of view of you're telling your colleagues, the ones who know deeply what statistics is about, what poverty measurement is about. So it appears that I am on board, and now we'll see if this works. Haha, does it work? It can. My friend Miguel Sekeli, my co-author and friend, had this wonderful quotation which came out of our discussion back in the early 2000s when we were working on the monetary poverty measure here in Mexico. He wrote this up in a volume called Numbers That Move the World. And you can read it for yourself, but I'll tell you the idea is that, of course, a number can awaken consciences, it can mobilize the reluctant, it can ignite action, it can generate debate, it can even, in the best of circumstances, end a pressing problem. Miguel has a way with words. I don't know if any of you, has anyone met Miguel here? You've met Miguel. Oh, great, so some of us know. I met Miguel when he was at an NBER conference, that's a National Bureau of Economic Research conference in the US, and he wound up going there and giving a talk. I was giving a talk, first time I met him, and he had his leg in a cast because he was living in McLean, Virginia at the time, working at the Inter-American Development Bank, and he had had an accident. He would ride his bike to work all the time. And so ever since that time, I remind him of the first time I met him in a cast. It's always good fun. Look, let's get bound to work. No more talking. This is now hardcore business. Okay, so I am going to remember the FGT approach, right? We did that yesterday. Let's remember it quick. These, I'm sorry, the slides are a little small for those of you who are in the back. I don't know what you want me to do. Have you come forward or move back, because there's a small TV just in the back as well behind you. But if you have any trouble seeing it, just in the middle of the lecture, jump up and come over here and look, or go back over there and look. Variable income, in identification as the poverty line. Here are the numbers we talked about in an example, a different example this time. Let's go through it again. 7, 3, 4, 8. Those are the 4 incomes. Poverty line, 5. We create the deprivation vector. This is the way I do it with all my students now, and they get it in 3 seconds. Create the deprivation vector. Who is poor? Well, this one and this one, the 2 middle people, right? 3 and 4 are below 5, the rest are above. 0, 1, 1, 0 is the deprivation vector. Oh, the deprivation matrix in the multidimensional approach. Yeah, right. Okay, continuing onward. Take the mean of this deprivation matrix vector. That is the headcount ratio. Right? Because it's 2 people out of 4 people, hence 1/2. Identify a normalized gap vector. So that means you take the poverty line minus the income over the poverty line, put that in for all people who are poor. Those are the 2 middle people. Clearly, we have a poverty line of 5 minus 3, which is equal to 2, over 5, 2/5 for the second person. The other person's got more, therefore it's only 1/5. All right, take the mean of this. Overall, the mean overall, add up 2/5, 1/5, 0, 0, and you get, looks like 3/5, and divide by the number of people, 4, and you get 3/20. It's as easy as that in calculating the poverty gap. Likewise, let's square these entries. So you're going to do the squared gap. Square 2/5, squared 1/5. You get 4/25, 1/25. Do you see what's going on here? We are actually emphasizing this poorer person, de-emphasizing the richer poor person, because look at the ratio, 1 to 2, this is 1 to 4. Really de-emphasizing the person who's less poor. Okay? Now, how do you define the squared gap? FGT? Easy. Take the mean of this vector. Add up the entries, divide by the number of people. So when you want to do FGT calculations, it's all just a mean. Okay? Every single one of them. All right, so let's move on. Alkire-Foster methodology. Look at this exceedingly small matrix if you can. If you can't see it, ask your neighbor what the entries are. Okay? There's no way to make it bigger, I guess, so I'll just have to tell you that there are numbers in each column. And there are numbers down here, too, with a little thing that says, looks like 2 parallel lines, but it's actually the number Z, the letter Z, or Z. Okay, so let me describe what these are. 13.1, a bunch of numbers. I could consider that to be income based in dollars, let's say. From my country, this is, 13 is about the poverty line for one grouping of people. And so 13, poverty line in terms of dollars a day. This is income in terms of dollars a day. Sort of following through the way the World Bank does everything. All right, incomes for the 4 people. Next, I have a crude measure of education. Horribly crude, but it's just about what we have many times. Years of education. Now, it doesn't tell you whether someone's behind in their education, doesn't tell you the quality of the education, doesn't tell you a whole lot of things, how far they have to walk to their education. Well, okay, but we take these data and go with it. Years of education. In the US, it's natural to consider 12 years of education to be a cutoff. High school degree. If you don't have a high school degree, many bad things happen to you. Literally. Look at all the correlates. Health is much worse. Job and earnings, much worse. So it's a good cutoff. If you do more than that, it tends to go up disproportionately. All right, so 12 is a good cutoff, and I see a 14 for the first person, 7 for the second. So you can see who is not achieving the level of the cutoff. Right, 7 is not. 14 is. And then we have 10 and 11, and they're both not achieving 12 also. See what I'm saying? Okay, so continuing on to the next dimension. Now I'm trying to measure health. Oh Lord, getting health data can be a challenge. What we're using here, just for the sake of the illustration, self-reported health. Now, self-reported health is absolutely a qualitative data source. That's what it is. You say, are you excellent, very good, good, fair, poor health? And then we assign the numbers to those categories, starting at 5 down to 1, or sometimes they do it 1 to 5 for some reason. In any case, those numbers don't mean a thing. These are 100% qualitative data. Okay, these are not quantitative data. Nonetheless, I'm going to use the numbers because that's how the data is going to come, and I'm going to interpret it knowing what 1 means, knowing what 5 means, knowing what 4 means in terms of those other categories. The cutoff given here is 3. That means that if you are below, because as we've done with income, we're doing below the cutoff, you're not achieving a sufficiency. So if you are below good, that means fair or poor, you are considered to be deprived in that dimension of health. All right, I see a 4, okay. 5, okay. I see a 1 below. I see a 3, okay. It's okay. That was put there on purpose so that we could see the distinction in this case. Finally, we have a very strange indicator over here which says, do you have access to a particular service? What is that service? I don't know. So electricity, okay. So access to electricity, exactly. Those who are not able to light up have 0s. Those who can, 1s. The cutoff is 1. That seems strange, but just think about it. It's below, right? So 0 is the only other possibility. Who is deprived? Can someone tell me through a telescope who is deprived? The 2 with 0s, that means the person 2 and person 3, we have it. So we have sussed out this matrix 100%. Right. I put underlines typically when I'm doing this to help myself remember who was deprived in the dimension. Got it? Okay. Now, if you look at those underlines, you notice that I could create a deprivation matrix from this by replacing the underlined values with 1s, those that are not underlined with 0. There we go. This is the deprivation matrix. There is one thing that we have to consider, though. All the time up till now, we've been kind of focusing on the actual counting case. There are instances, in fact, it becomes very regular that we apply differential weights to different indicators. Now, different dimensions, maybe not, but I'm not going to distinguish between dimensions and indicators here. I'll just say they're kind of the same thing. You will see later that there are dimensions, and then within dimensions, indicators. The usual way we approach it is we have equal weight for equally important dimensions. And then below that, we see the indicators and which one should we say has more weight? And we get to another equal weighted case. But that will be part of the discussion when we get to the setting of weights later on, okay? Normative weights. Nonetheless, I wanted to open your mind to the fact that we could be having weights here that are differential. They could add up to 1, they could add up to the total number of deprivations. It could be general. Here, I'm going to add them up to the total number of deprivations. So I'm going to have 4, but it could be that I put more weight on one and less weight on the other. So you could have 0.5 on one and 1.5 on another. See what I mean? You can also interpret that in your head as the percentage. Either way. So let's see what we do when we have differential weights on each of them. Well, one quick way is to take the cases where a person is deprived and say, hey, I can remember that you're deprived in this, and here is the weight of the deprivation. Here's how much I consider that to be important relative to the others. Okay, so if we replace the 1s with WJ, where WJ is W1, W2, W3, or W4 for the appropriate column, then you have the weighted deprivation matrix. Got it? Does this all make sense? If I've confused you, send me back, because I can go ahead and recover that. Okay. So, deprivation matrix, or the weighted deprivation matrix. Now, if we have equal weights, where the weights are each weight is 1, so they add up to 4, we're back in a world where the two matrices are actually the same, right? put in ones. They're the same. Okay. So we will tend to, in our illustrations, talk about the unweighted case or the equal weighted case. But we will also tend to give you some examples of weighted so that you can start approaching your own real world problems, which typically require weights. Okay? Okay, so here is the equal weights, and I'm back to the deprivation, the weighted deprivation equal the deprivation matrix. Got it? Makes sense. Okay. Now, what should I do in determining who is more or less deprived? Well, a natural way is just to take the weights, add them up, and see who has a greater aggregate score or count, and it's given there to the right. The first person, thank goodness for the first person, not a single deprivation, a 0, which in this case, 0 means good. Okay? Okay. 0 is the count. The next person has 2, the next person has 4, the next person has 1. Notice, I have ignored for the moment which deprivation they're deprived in, because I'm just going to add them up, and right? Now later on we'll decompose or break down, and we'll find out which ones that people tend to be, and that will be informative. But for right now and the big measure, this is the way it's constructed, kind of ignoring it for a moment. Okay. Who is poor? This is a big question. And as we saw before, it depends on what your K is, your cutoff is. So let's suppose that we go to one extreme. Some people may have said that when Chris was talking. I forgot whether someone said, you can be deprived in anything, and I'm going to consider you to be poor. That's a union approach, because if you look at the Venn diagram, it's everyone who's right inside has a deprivation in any one of them. But all the other people outside are not included. But all those in any one of those Venn circles is considered to be poor. Okay? So they're poor. So let's see who would be considered poor if Ci greater than or equal to 1 was the thing that indicated whether you were poor or not. So the cutoff is K equals 1, as I'll describe it in just a second. Who would be poor? Better yet, who would be non-poor? That's right. And who would be poor? Everybody else. So indeed, we see the underline coming underneath the people who are poor again to tell us, now this is who are poor. But this is a big problem. In the small words that are written at the bottom, it would say the union approach, which we're talking about, the union of those Venn diagram circles, predicts a very high number. And I can guarantee you that you're seeing that as people talk about poverty in any country, actually. They often will use a union approach when they think, and I think it's slightly misguided, because it really is an amazing thing, because you're combining all the ministries at once to say anything that's any problem, and any ministry becomes our problem. So no, it's not. We have a separation of problems. So that's what union approach is about. It actually has been used a lot. It was the basis of all the research in multidimensional poverty for many, many years. It now is not been used very much in practical terms for good reasons. Let's take the other extreme. We've been over here. Anyone who's deprived is poor. Let's go. Union, let's go back. Union means that no matter who you are, if you're deprived in this column, if you're deprived in this column, if you have a 1 in one of your columns, you're poor. That's what it means. And the way we can see it is we've added up the columns here, and we see, that's greater than or equal to 1. Now notice, greater than or equal, that's confusing. Because when we think about cutoffs going down, it's less than. Now it's greater than or equal to 1. The cutoff, or the target of 1, that is, when you achieve that, you are poor. Okay? So that will be a little bit of a difference between looking down in deprivations to when you look across to see who's poor. Just remember it, and it's okay.
In this case, any dimension is the same as at least at one dimension.
That's it. And you're called poor then. If anyone is deprived in it, we could see everyone in the room and check out if anyone was holding their hand ever, I'm deprived, then you're poor also by definition of union. So let's go to the other case. Now we search around. It's all the way on this side of the floor. We search around and we say, okay, who held up their hands every time when we asked, are you deprived? You're poor. Everyone else, you held up your hand once, twice, 3 times, no good. You're not considered poor. Only the people who are in the very center of all the circles, the intersection of all the circles of deprived people, you're deprived in every dimension, you're considered poor. Okay, does that make sense? Okay, in that case, let's see what happens. Intersection case. We're requiring CI equals D, or 4 here. So the only people who are poor have 4 deprivations. Punto. Right? All right. So who in the world is poor here? Mr., Miss? Third, you're right. So this is underlined, none other is. The problem with intersection is, I don't know, if someone started with intersection, I would say, man, you're trying to make poverty look too small. That doesn't make sense. On top of it, think about it. If someone just happens to be deprived, well, just think about it, it's very demanding. So empirically, it's a problem as well, right? So I don't know. There are issues. You can think about it in the extreme one way, in the extreme in the other way. Both of those extremes have problems. That's all I'm saying. Now, here's an example of why you might have problems. Yes, please.
What do you mean by
demanding? Demanding? Well, let's see it in this example here, okay? So, if you look with poverty in India for 10 dimensions, this is using data gathered up in the previous round of India data. We see the union approach will say that 91% of the people in India are poor. That's very lax a requirement, since it's allowing many people to be poor. Remember, part of the reason we're doing this is to be able to target the poor, prioritize the poor, and if everyone's poor, you're not doing a good job. Now, if the fact is that many are poor, then, maybe. But the point is that the smell test for many countries would be violated by the union approach. Likewise, if you come down here to the intersection, in the intersection approach, great. India has solved its poverty problem entirely. Very demanding criterion in order to even have a person get into it, to be considered to be poor. Right? So that's what I mean by demanding. We need something in between those, and you can see here that in between you have a number of possibilities. Okay, that's the example just to get you thinking about these two extremes and ruling them out. So let's take something in between. Fix a cutoff K. Someone is poor if CI, the count, is greater than or equal to the cutoff, poverty cutoff K. Are there any questions? Okay, so let's continue with this example. I'm going to follow the way that Chris had it. K equals 2. If you have K equals 2, then you know that these two middle people are poor. Just look at it again. You have a 0, so that person's out all the time. You have a 1, and that is the person we're going to miss in terms of poverty. So this person is education poor. Education deprived. Did I say poor? Never let me say poor in one dimension, because it's deprived for our conversation here to keep the two separate. Okay? So education deprived, and the Ministry of Education should deal with that person for sure. Okay, but they're not poor, so therefore the two middle people are poor, and that's our topic here. Okay, so why don't we recognize that as the Ministry of Social Development, or as Coneval, that we are going to be talking about poor people. So the data for the non-poor people become irrelevant, except that they're there as part of the population. Censoring is what does that. So if you take this weighted deprivation matrix, it has a line over it indicating its weighted deprivation matrix, but it has a function of K. It has a parenthesis, K, parenthesis. To remind you, it depends on K. Here, K equals 2, so you can see. So, let's put 2 in there. That's all I'm saying. All right. So who is poor? We've got it. We can now measure the headcount ratio. So 2 people in the middle out of 4 people. Headcount ratio of, it's a half. So that's it. easy, wasn't it? Identification gets you the next step to headcount ratio very easy. Okay, let's take a look at this though. As we said before, if the number of deprivations were to rise for the first poor person, number 2, notice before it was 0. Now the person is deprived in income as well. What happens? For the headcount ratio, nada. Nothing. So, no change. This violates a particular form of monotonicity in the multidimensional world called dimensional monotonicity. If a poor person becomes deprived in another dimension, okay, then that person is obviously poorer, and the poverty measure should represent that. Okay, violated here by this measure H. Because what happens? A person has now become deprived in income they were not before. They were they were poor before, but now they're deprived in another dimension. You should consider more poverty being there. Now, it isn't any more people who are poor, but it's a greater breadth or intensity of poverty. If you're more multiply deprived, you're considered more poor in that sense.
But the MPI would reflect that in the intensity, right?
Thank you. Yes, since I am just developing the MPI, you're a step ahead of me. The MPI does reflect it in the intensity. Let's put it together. So what data do you need on top of this? Why don't we use the deprivation shares among the poor? It's 2/4 for the first person, 4/4 for the second person. That average deprivation among the poor, thank you very much, is 3/4. That extra data that the poor are so poor, 3/4 in their average intensity, could be combined with the headcount ratio to get a new measure. Now, it's not very new now, but I'm treating it as if it's new. The new measure is M0, the adjusted headcount measure. It's adjusted by the intensity. Okay? All right. So we take H times A, 1/2 times 3/4, and we get, I don't know, 3/8, which is 0.375. All right, there's actually another way to figure it out, and that is, why don't we take this matrix and look at its mean? I'm happy with calculating means. Most statisticians are extremely happy to calculate means because they're easier than medians or other sorts of weird things, okay? All right, so let's do it. We add up 1, 2, 3, 4, 5, 6. How many overall? 4 times 4 is 16, and therefore we get the same number, which is 6/16, 3/8, hence 0.375. All right. So as Chris did it, the way you can separate those two out is that you look at the mean of this little matrix of the poor folks. That's what A is. Multiply that times the headcount ratio, which is 1/2, and the N in the bottom of the headcount ratio becomes the denominator of the adjusted headcount ratio, replacing the Q, which was there before, under the intensity. See what I'm saying? So that's what happens here. This is the measure. Let's move on. Well, just to check on your point exactly, which is if that person becomes deprived, person 2 in money, then clearly in going from a 0 to a 1, intensity goes up. For that person, the share of deprivations goes to 3/4. Take the average. The average is 7/16. The average is 7/8. Multiply it by 1/2, 7/16. And of course, we now have a larger number for M0. Does that make sense to everyone? This is an important point. Important point. Yes, please.
Question about the intersection approach.
Yes. Let's go back to the intersection approach. Forget about this for a second. Let's go back to K equals what? K equals what?
All the dimensions.
4, exactly.
Okay, so if we want to compare it to the income-based, expenditure-based approach,
Yeah.
where you have, so you're monetizing all your needs, and you create the poverty line based on the minimum you need to
Okay.
actually be non-poor.
Okay.
So actually this matches perfectly the intersection approach, correct?
So the intersection approach would say that you have a cutoff in each of the dimensions of, let's say, types of income you get. Earned, unearned, 2 types of income. You're adding those up, aren't you? Or you could do it in terms of consumption, which would be different. But let's do it in terms of income, because they have equal weights then. Yeah. So you have earned and unearned income. The additional bit here would be you'd have a cutoff in earned income and another cutoff in unearned income. And anyone who fell below in either would be considered to be poor. So it'd be very different than someone who falls below in the sum of the 2. See what I mean? So the fact that you're taking the sum of them up and then setting the cutoff means that you're doing the average, and someone could be way low in earned income, or someone could be way low in unearned income, and they, right, so there's the difference.
Intersection is even more extreme.
It is. It's more extreme than what we're talking about here in many, many ways. Thank you, yes. Good question. All right, satisfies dimensional monotonicity. Let's go on. The adjusted headcount ratio conveys information on deprivations among the poor, right? It is. It's adding up the deprivations among the poor in the equal weighted case and dividing by the total number of potential deprivations that society could exhibit. Another interpretation of the measure, a nice one. Notice that that third column contained an ordinal or qualitative variable, self-reported health. Didn't matter, because all we need to know is whether you are deprived or not. I could go one step further. Even if I didn't have any numbers at all and I just knew who was deprived in a dimension and who wasn't. That's all I need. So sociologists, anthropologists, this is the way to go. Because if you can make that discernment as to who's deprived or not by whatever criterion, it can be applied here. So it's quite general. For many, many, many situations, it's quite possible to use this. Third, simplicity. Did you find it easy to compute? Take a mean of a matrix, for goodness sake. Multiply 2 numbers, for goodness sake. I hope it's easy. Has useful properties that we'll talk about in a second, subgroup decomposition, dimensional breakdown. We'll explore that in just a bit. And it's expandable. If variables are all cardinal, we have indices that follow, that take into account depth, because the variables might be ordinal or qualitative, therefore we can't measure depth. We don't. If you can, we've got a measure for you. Okay? But we won't talk about this here. That's in the book, and it is the adjusted poverty gap measure or the adjusted FGT measure. You can imagine how it's going to be done just by thinking about how I defined the poverty gap and the FGT. Similar, very similar. Continue. Let's talk about dimensional breakdown and, subgroup decomposition, also called disaggregation by people. All right, so what is the so-called uncensored headcount ratio? You may wonder why we're saying uncensored headcount ratio. We really should say censored first, but I'll start with uncensored. Uncensored means you go back to the original weighted deprivation. Actually, it's easiest with the unweighted because that just gives you 0 and 1. It's just so simple to calculate. Add up the number of people who are deprived in the dimension and divide by the total number of people. That's it. So, how many people what is the uncensored headcount ratio for electricity? Access to electricity. 2/5. Exactly. How about for income? 3/5. So you see how easy that is. Okay. Now, you're implicitly here, if we had weights there instead of the 1 and so forth, you would have to divide through by the weight because we have the weight there. And when you're adding up, you add up the weights and then you divide by the weights to get us back to the 0-1 case. That's all. So let's see what the definition is. It says, take this column, right? Right. Okay. Now let's go to, so take this column, add up the entries, divide by the total number of people. That's the definition, the uncensored. Now let's go to the censored. Obviously, we're not going to use the uncensored matrix. We'll use a censored matrix that gets rid of the entries among people who are not poor and replaces them with 0. So we've done that here, I hope. I think so. In any case, If this is the censored deprivation matrix for k equals 2, then what is the censored headcount ratio, the percentage of the population who are both poor and deprived in dimension 1, in the income dimension? Well, you can see it just by looking at the table there. The same thing. Add up the number of people who are both poor and deprived in that dimension and divide by the total number of people. In this case, 2/5. Does that make sense? The difference is we had that 1 there before for the non-poor person. Now we have the 1 is gone. Okay. All right, so we do this for all the columns, and we can see what's the censored headcount ratio for self-reported health. 1/5 is right. Thank you. So that's the way you calculate it. And here's the formula. It says the censored headcount ratio for the jth column, given that we have the cutoff of k, is equal to the mean of this censored deprivation matrix column, which is denoted by G hat 0 dot J of k. Forget about it. Just know what I'm talking about, right? Okay. Divided by whatever the weight is. Weight is 1 everywhere, so it's very easy. Add it up. And that's how you get it. Okay? Does this make sense? Okay. Censored versus uncensored headcount ratios. Let's read what it says. The uncensored headcount ratio of a dimension denotes the proportion of a population deprived in a dimension. Of a population, the society. The censored headcount ratio of a dimension denotes the proportion of the population that is both multidimensionally poor and deprived in that dimension at the same time, just to push it home entirely. Any questions on this? All right. So the Ministry of Education would be interested in which? Yes, so censored or uncensored headcount? Uncensored, yes, uncensored. The Ministry of Social Development might be more interested in the censored because it's interested in poor. So that's the point I was making. Okay? Exactly. So what are we doing here? We're just going to run through that again? Okay, let's run through it again. How about it? We got 2/5 here. We got 1/5 here. The other two, you can see what we're doing? Right. I'm done. Next. So, yeah, the weights are equal to 1. This is just reminding you that the MPI can be expressed as the weighted sum of k. Where, do you see? If you take the MPI can be expressed as the weighted sum of the censored headcount ratios. Well, you use the weights on each column, add it up, divide by the total weight. This is really useful. So, I mean, MPI is really kind of the average of these numbers here. So the smallest it can be is 1/5. The largest it can be, the adjusted headcount ratio, 3/5. So it's between the two. This is easy, right? So you're just averaging them up to get the score, which we call M0. All right. Yes, please.
I was just thinking of these two matrices that we looked at yesterday. One with the D's that are like going through the lines and one with the D's in one line, right?
Yes.
Telling us which people are deprived in multiple
Absolutely.
dimensions. Does now what we looked at in the previous slide reflect that or not?
Yes, so that's a very important question. At what point do we differentiate between those two matrices, therefore differentiate between the joint distributions? Exactly. Where you do it is an identification and the censoring. Because if everyone, right, now in that case, if k equals 1, you don't, right? Actually, if k equals 1, no one is poor in that society, no? K equals 2, I mean, no one is poor in this society. The one with the diagonal, right? Since you had only one deprivation for every person. Okay. Whereas the one where you have one person with every deprivation, you get one person who is poor, and the rest are still not poor. So therefore, there's a differentiation even in that extreme case of the matrices we saw yesterday. right? So if you have 1, 1, 1, 1 for the C's, the cutoffs, right? The counts, I mean, not cutoffs, counts are 1, 1, 1, 1 for each person has 1, then if k equals 2, you have to have 2 of them to be poor, and no one is poor. But if one person has each one of those deprivations that they're suffering at the same time, they're considered to be poor, so you now count that person as poor, the others are still non-poor, and it's different. So there is a difference between those two matrices that we saw yesterday. We'll talk about it later. But I can tell you one thing. We could also talk about setting Z or Z. Again, setting Z has a whole lot of arbitrariness in it, don't you think? Yeah. So therefore, K, I would presume, would have a whole lot of arbitrariness in it. It does. You'll wait. Excellent. So here we have the statement I just made, which is that we can decompose, or now we call it breakdown if it entails dimensions. We can break down M0 by dimension or reconstruct M0 from the censored headcount ratios by just averaging them up. Okay. Also, you can call, let's go back to the picture. It's a lot easier to do it this way. What is the contribution of this? Okay, well, what's the overall level? You take the overall level here, put it under each one of these. Take the average and put it under each. Okay, so what you would get is a kind of a sense of the contribution, but then it wouldn't add up to 100%. To make it add up to 100%, you divide by the total number. So you want to then take this definition here, which is Hj over the average, but then pre-multiply it by Wj. In this case, it's 1. D, which is 4 in this case, let's say, or 5 in this case. So you divide through by the total number of deprivations, and that would give you the contribution of the indicator to the total amount of M0. And what does that do? It allows you then to see what is the percentage contribution of first dimension, the percentage contribution of second dimension, third, fourth, fifth, and they add up to what? 100%. All right, so that's breakdown. Really important. Notice we've done that one first because it's something that's unique to multidimensional poverty. Example, an achievement matrix with 4 indicators. Boom, 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 boom. Z is the dimension of deprivation cutoffs. Do you agree that that's the deprivation matrix? Look carefully. C12, who is it deprived? 1. Access to electricity. There you go. You anticipated the slide. Access to electricity. All right, so we can see who is deprived, who isn't. Now, I'm going to run through this. I'll send you, make sure you have a copy of these PowerPoints. So you don't have to write this example down. Just understand it now. Later, we can write it down. But there we contribute create the deprivation matrix. With ones, the first person has no deprivations. The second has the first and the fourth deprivation. Third person has all of them, etc. What's the uncensored headcount ratio? Shout it out. I'll point to it. You shout out the uncensored headcount ratio. One half. I heard it. 1/4. 1/2. Half. Done. Uncensored headcount ratio. You can calculate from this matrix. Now, replace the deprivation status with the weights. We can see it here. Okay. Now this is a case where the weights are such that a weight of 1 here, weight of 2 on years of schooling. Wow, we were really interested in emphasizing education. A weight of 0.5 on sanitation, a weight of 0.5 on access to electricity. Okay. This would be the deprivation matrix. Now with the weights put in, Yes, I heard that. Let's construct the deprivation score vector. Boom. Add them up. Add horizontally. I should have just had you calculate these, because you could. 1 plus 0.5, 1.5, etc. 4, 2. Is this understandable perfectly? Okay, now we haven't censored yet, because we're still trying to figure out who's poor. All right. So if k equals 2, again, begging the question that was asked over here, how did you come to k equals 2? For an example. For example, k equals 2. Tell me who's poor. Okay, excellent. So now we know who's poor, and we can circle them and remember who's poor. Then we're going to censor the deprivation matrix, the weighted deprivation matrix, and here we are. All right, that's a censored deprivation matrix. Right now we can immediately jump to the MPI. M0 in this case is add up the entries and divide by 16. 1, 2, 3, 4, 5. Out of 16, oh, did I add bad? 1, 5. I keep making mistakes. Am I making it? Is it really 6/16? I'll believe you. I'll let you be the teacher. You teach me. 6/16. Adding up these and dividing by the numbers, we get 6 out of 16. Another way to see it is, of course, I made my mistake. You can add these two up and then divide by the total number of people. Hello, folks. Good to see you. All right. What's the censored headcount ratio for each dimension? So I'll point to it and you tell me. What's the censored headcount ratio? Sorry? For this one? 1/4. Remember, you take it, you add up the entries, then divide by the weight. Or my way of doing it is that I imagine the 0.5 is actually 1. And then I see 1 out of 4. That's the way my head uses it, okay? You may find that a little easier. Likewise here, I have 2 out of the 4 who are deprived. Otherwise, you could add it up. 2 plus 2 is 4, divided by 2 is 2. Same thing. Does this make sense? I'll point to another one. What is this? Censored headcount ratio. 1/4. That's easy, isn't it? I'll try to disrupt your mind again. What about this one? 1 out of 4, exactly. Thank you. Okay, here are the numbers you just saw. Okay? Is everyone happy with this? Okay. Censored headcount ratio and the percentage contributions. The censored headcount ratio of indicators. This is sort of repeating it again, right? Where you take this here, add them up, where WJ is the weight attached. We make sure that we have that weight, and the weighted average, blah, 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 blah. Same thing that we've done before. Contribution is equal to this. So when you add them up, these entries here add up to the total amount. That's the point. Except, you see? So that's the point of this, is that it becomes a very nice way of being able to divide up by the dimension and bring it back up to the total. So let's see, the contribution of the education dimension to MPI. Contribution, education is not there. Good Lord. Look at that. Education, years of schooling. Indeed. Contribution. 2 is the weight out of 4 times 2/4 times 6/16. This headcount, censored headcount ratio. Total amount, 2/3 comes from that column. You could do this for each column, and I encourage you to take an example and run through in your own time, column by column, make sure you know what each entry means. Right. Okay? So you will have these slides, work through an example. All right. Let me ask you some questions. These are conceptual questions. They're not particular example type questions. First, What's the difference between the uncensored headcount ratio and the censored headcount ratio? Do you know? Go like this if you do. Go like this if you don't. Well, and if you don't move at all, what should I think? Yes, please. Yes.
I get lost in why did you change between 1 to 0? It's because of the definition.
Right, who is poor? And that person with just that one in the one row, one column, I mean, that person doesn't have multiple enough deprivations to be considered poor. We need 2, at least, for this approach.
You erase it because you don't have enough amounts of deprivation?
That's true. What it is for that person, much like when you're figuring out income poverty, you will say, well, why don't we take into account the incomes of the rich people? Well, we don't. They're just a dummy sitting there. We put a 0 for them. Likewise here, for the non-poor people, we take each of their deprivations. It could be 1, if it's more, whatever. But whatever they are, however you define the number of poor, whoever is non-poor, you put a 0 for their deprivations from now on, because we're going to calculate information about the poor people, not non-poor people, right? So that's the intuition.
So in that sense, how could you compare between countries?
Well, the same way I would compare between the same country over time. If deprivations fall, or if there's a number of people that have very few deprivations and they're not considered poor, like with income. I don't consider their incomes when I'm talking about poverty across, right? So as long as you have the same individual cutoffs and the poverty cutoffs, the deprivation cutoffs and the poverty cutoffs, as long as you have the same ones across country, you can compare. If you don't, then of course don't go comparing across countries. Don't look at Panama's and compare it to, I don't know, let's say Colombia. It'll be very different, as it should be. But if there's a regional MPI for the entire region of Latin America, then by definition it's constructed in common to compare across borders. Okay? I hope that makes sense. Good. So when we're doing the uncensored versus censored headcount ratio, the censored censors, makes it so we're not looking at the deprivations of the non-poor. They don't have a voice in this discussion. I'm sorry. The people with a voice in our discussion are the poor. Yes?
In the previous slide,
yeah.
Yes. In the last part of the formula, 6, what represents that 6 before 16?
This one here?
Yes.
It's those, in essence, for the simple way of calculating the MPI, it is the numbers of deprivation over the total numbers that would be possible. Remember, it was weighted numbers, so when we added up the weights, we got 6. In other words, I took the deprivations I did it wrong, remember? I calculated and said I got 5 because I made a mistake. But instead, the number, when you added up the 1s and the 2s and the 0.5s, you added them up for all deprivations among all poor people, we got 6. Okay? So if you go back to the previous slide, we would see that. There's the 6. Add them all up. Okay. Okay? Thank you. So now back to the questions. I hope you understand this difference between the censored and the uncensored headcount ratio. In any case, it's something you know at the gut level. You can calculate it yourself in your own time to make sure you get it every time. Next. Can the uncensored headcount ratio of a dimension be lower than its censored headcount ratio? No. Because in one, you're considering the deprivations of the non-poor. In the second one, in the first one, you're considering the deprivations of the non-poor, so you're going to have higher number. Whereas the one where you consider only the deprivations of the poor, it's a lower number of deprivations, or equal, if everyone who is deprived happened to have been poor. Okay? So, One is less than or equal to the other. Remember which it is. Censored, less than or equal to the uncensored headcount ratio. Okay. Can the censored headcount ratio of a dimension be higher than the multidimensional, oh, this is really tricky, headcount ratio? Can it be higher than the headcount ratio? Gee, 2 people might be poor overall. Oh. So if you look only at the deprivations of the poor, it looks to me that you're limited by the number of people who are poor. So that'd be 2 maximum. If both poor people were deprived in that dimension, you would only get the headcount ratio back. If you had one person, right? So I'm doing 2 out of 4 in this case. You would have 1 out of 4 for the censored headcount ratio. If no one who was poor was deprived in that dimension, you would have 0 out of 4. So the censored headcount ratio would be 0 in that case. Could it ever be above? No, you're not going to pay attention to those other people. They have zeros. That's why. So multidimensional headcount ratio, that means H. People will make a mistake because they'll think I'm saying the adjusted headcount ratio here. But it's the multidimensional headcount ratio. So the censored headcount ratio is always limited in every single dimension by the headcount ratio itself. Okay? Okay. I'll come back to question 3. I'm going to modify it and leave it as a problem for you. What's the relationship between the censored headcount ratios and M0? M0 is the blank of the, that's right, weighted average of the censored headcount ratios. That's what it is. So it's very easy to think of. You're just averaging up. If you have no weights, if they're equal weights, then it's just a pure average, otherwise it's weighted. This is crucial and interesting. What kind of policy analyses can be conducted using the censored headcount ratio? Can you imagine what you can do? So you can start imagining, wait a minute, there's no one who's poor who's deprived in this dimension. Should we really be focusing on this dimension? Of course not. Right? If everyone who was poor turned out they were living in parts of town that got good education. Oh, if that could only be the case. Okay? If every poor person in the country was getting an adequate education, was going up to the 12th level, and wouldn't it be a lovely world? And let's suppose that some other people were not. People who weren't poor. Then it wouldn't be our discussion in the social development ministry to talk about education. I'm sorry. That'd be the Ministry of Education. Okay? Okay. So this tells you where you put your emphasis to an extent in order to be consistent with the way you're measuring poverty. Now, you'll have to think about it deeply. And it's not obvious that you're going to go after the one with the best contribution, the highest contribution. It has to be textured. You have to think about it carefully. It may be you can't do much in that dimension right now. And so what you wind up choosing in terms of policies to attack poverty depend on many other things that I'm not going to cover through measurement. But it at least tells you where the bang for the buck is going to be for you in terms of the measure itself. It won't tell you the cost structure. It'll tell you the benefit structure. Okay? Oh, and I promise you I'd give you a question here. Suppose I had said M0 here. If instead of the multidimensional headcount ratio, I said M0. Remember, the censored headcount ratios are average. Some higher, some lower. You average them up, you get the M0. But some are higher, some are lower. Yeah. Therefore, you can't say this. You know that the censored headcount ratio, yes, can be higher than the multidimensional. In fact, there's probably one that is, unless they're all the same. And some are lower. Because it's an average of all of those, what M0 is. That's the advanced question. Go back and think that advanced question through and make sure you can answer it. I'm going to continue. Yes? Yes, remember the averaging that we did? It was in a slide before. It said that if you have censored headcount ratios for each dimension, let's take the equal weighted case. Just average them up and you get M0.
So it's linear or it's the same?
It's average of them is that. Now, otherwise you have to use a weighted average. But it's, right? So you get them. If you had every censored headcount ratio being a half, then yes, M0 would be a half. If one was 3/4, one was a half, and one was 1/4, you'd get a half.
So the relationship is a correlation?
It's a linear relationship by definition.
Good.
Okay, thank you. All right, now disaggregation by two regions. I'm going to rush through this, okay? We have the overall matrix that we were talking about. We have the overall level of M0, 2/5. You could calculate it. I could also think of this group of people being one region, this group of people being another region. So you guys are at the top, you guys are at the bottom. These are your numbers. I could calculate your own M0s. Your M0 and your M0. How would that link up to the overall M0 for the country as a whole? If it's the case that there isn't one of you who runs back and forth between the groups, so you're in this group and this group, no. So that's mutually exclusive. Or there isn't someone who runs out of the room when we start measuring, right? Then we can do this. We can do this. So how do we do it? We calculate region 1. Suppose we have k equals 2 with equal weighting, okay? So this is going to keep equal weighting to make it simple. What's M0 in this case? 1/3. What's over here? 4/8, 1/2. Exactly. So now we have the two MPIs. Remember, MPI is a mean. So you know how to average means. If I got the mean of this group and the mean of this group, I know what I would do for, say, GDP, for income. I'd take the weighted, population share weighted mean of this one, plus the population share weighted mean of this one, and I'd get the overall mean. That's what we do. That's simple. Okay, so you take population share for group 1 times M0 of group 1. Add that to the population share, group 2, M0 of group 2, and you get the overall M0. If you don't believe me, just look at those numbers. Okay? So we had 3/5 times 1/3. Could someone calculate that? That's 1/5. 1/5, and this one? 1/5 again. 1/5 plus 1/5 would be 2/5, and that's what I had claimed it was at the beginning. Satisfy yourself, it is that, because we count them all up, 1, 2, 3, 4, 5, 6, 7, 8, out of 20. 8 out of 20, 2/5. Gee whiz, isn't it wonderful when you're standing in front of colleagues trying to explain something and the numbers don't work? It's the worst time of your life, isn't it? Okay, let's continue. So overall population, overall poverty is a population share weighted sum of subgroup poverty levels. Now, there's a caution. This is written by Sabina. When you're reporting these things, be careful to put population shares, because otherwise people get confused. They see two subgroup numbers, and then they see that, oh, these don't average up to the overall. They say, what's going on? But if you put the population shares there, you will remember and do the appropriate weighted average. Reporting conventions. That's all I'm going to give you in terms of hard stuff. This is super easy. Okay? It's just something for you to remember. I don't need to teach this. We can stop now. You want to ask questions on what we've done before? Let's do that. Any other questions that remain besides k equals 2, which thankfully someone else will cover entirely? No questions? Is it more or less clear? Clear? Okay. Yeah, so you have to work through it. That's the whole point. We will have to work through example after example. Then it'll be nailed clear. Okay, then I'll go through the conventions and then we'll be able to stop. Number one, MPI, the adjusted headcount ratio. That number is typically reported as decimal. We've been doing 1/5 or 3/5 or whatever. That's for examples. When you're reporting it, it's easiest, we've found, by doing it again and again, to just say, look, 0.352, 0.532. Sorry, 0.352. That's how we'll report it when we have it. What is it? It's the main official poverty statistic. Certainly global MPI, this is how it's done. Interpretation, the share of possible deprivations that poor people are experiencing. So if we had all the people here deprived, all the deprivations that could be there, this is the share of them that are being realized. Like we said before, among the poor.
Why in this case you put possible deprivation as equals some probability?
Yeah, I know, it's total really. Total. Total possible, meaning total. If it were the case that everyone was totally deprived, here's how many. That possible, okay? So it's maximal. Thank you. That should be corrected because we have a room that contains statisticians and probabilists, and therefore it does cause trouble. Thank you for that. Why? Sabina? Not here. Why? Because it's coherent. If you put them in percentages, it gets mixed up with the headcount ratio and people go crazy. We'll see in just a second, okay? Headcount ratio we report as a percentage decimal. That means the frequency, right? The percentage of the population that has this condition. Therefore, it separates the two measures a bit more. We found people were mixing them up, right? So Sabina can tell you all the details of 1, 2, 3, 4, 5 situations where she saw this at this country, this case, etc. But hence the convention. Headcount ratio percentages. For instance, 56.1%. That's easy to understand and interpret. You immediately get it. No need to explain. Okay? Now, sure, this is a percentage of all possible, the maximum possible deprivations. But that isn't what we'll focus on because we don't want people continually thinking back to that. We just want this to be considered the statistic. Intensity. Okay, so what is, the headcount ratio is an easy to understand second most important statistic, which interpreted as the percentage of the people who are poor. Intensity, that's the sum of the deprivation scores or over the total number of the poor. How do you report it? Again, percentages, she finds most useful to report it as percentages. There's going to be confusion no matter what, but this lessens confusion. What is it? A measure of breadth or multiplicity of deprivation? Interpret average deprivation score of poor people. So when we do stuff here we'll do it as percentages. When we take this average, we see the percentage. We multiply everything by 100. Sorry, guys. It's just the way it is. That's how we've found for a long time that it makes it easier for people to understand. Now, I know it really doesn't matter because if you can't multiply two percentages and get a decimal, then you're in trouble. Okay? It will make it, it won't look like it's right because the number you get, if you don't remember that you've multiplied by 100 in two cases and you have to divide by 100 times 100, you're going to be in trouble. But you'll remember it. It'll be easy. I guarantee this is not a terribly difficult thing to remember. Second, third, fourth, censored headcount ratio. You get one of them for every indicator or dimension that we use. How do you report it? Percentage. It's a headcount ratio, so it's like the headcount ratio. So 10.8% of is what this would be. That means that the interpretation, the percentage of people who are poor and deprived in an indicator. What is it? It's an easy to understand view of the deprivation level among the poor. And society, where you take everyone who's non-poor and give them 0. So you're really trying to get an understanding of where the deprivations are among the poor. We're really trying to get into to the data and understand where poverty is arriving from in M0. Yep?
In this case, remember one of the questions, as was question 1 or question 2? Question 1 was the difference between censored and uncensored.
Yes.
Can we say that here in these phrases that we have, that the main difference between censored and uncensored is that in censored headcount you have pool. That means that you have to cut off someplace.
That's a cutoff is
the
someplace.
second one, you don't have no cutoff.
Exactly. So you have no cutoff for the uncensored. In fact, you ignore the cutoff entirely. You are looking at every person and saying, look, I'm going to look at the actual deprivations of people. I'm going to account for them. That's my uncensored headcount. Yes?
So if you're talking to the Minister of Education,
yes.
You would tell him to look at the censored or uncensored?
Censored if you're looking at poverty. Uncensored if you're looking at education. Right, because you want to know the percentage of people that are deprived. But even then, the deprivation cutoff may be wrong. Because education, our target everyone receives 2 years of college in the education ministry. It could be quite different, right? And it should be. But the concept is the same. Who is not achieving this cutoff level? In fact, I bet the Minister of Education would be interested in knowing the percentage of the population that doesn't achieve this level, this level, this level, this level, all the way up to college. The distribution. But we're not. We can't be. All right. Percent contribution, 1 per indicator of the MPI, how to report it, percentage. So that's the percentage in terms of the censored headcount ratio, right? How much is this dimension or indicator contributing, taking into account the weight, taking into account the censored headcount ratio, right? How much is it contributing to the overall M0? We report it as a percentage. I mean, percentage contribution, I guess. 20.1%. That's a lot for one dimension. That's a lot of contribution in that one dimension. You look at all the other dimensions and they're going to add up to 100%. Okay. Yes, please. Yeah, I'm saying that's a lot. It does not.
Maybe the other one are also 5 of 20. So in this case, I was
so let me pull back from that and say importance has normative impact. Large doesn't, so I'll say large. That's pretty large if you have 4 or 5, right? It's okay. I mean, that's significant. You know, now that's, again, getting to the statistician. If I say significant, I'm going into another problem. So forgive me, I am not a statistician, and so I tend to use it the way the common folks tend to use those terms. But anyway, let's continue. So what this interpretation, what it is, it's a guide to policy that reflects the weighting structure. The interpretation is the MPI is made up of the weighted contribution of each indicator. It it communicates how much each indicator contributes to the level of M0 or the MPI, okay? Contribution. Contribution is just a number. The sum of all contributions is the MPI. So percent contribution versus contribution. Percent, you do it one way. Contribution, you do the other. Don't ask me why. Look, you can understand it just by reading it. When you report it, people will probably tell you. I bet if you report it differently, people will understand. But it's just the way that the reporting conventions work out here at OPHI, and that's it. Is it coffee time? Let's go. OPHI coffee time. I didn't ask if you had questions, but I've been asking all along if you've had questions, haven't I? And the one question I won't answer is one we'll cover later. Really. But in practice, I can tell you that when you try to figure out K, it takes some sensitivity, looking at the different Ks, seeing what's going on. What some groups take and compare the headcount ratio you get for a given K to the currently used poverty approach.